Hello everyone, in this video we will be discussing the second case of the technique in solving improper integrals with infinite limits. So ang kaibahan lang ng case na to sa nauna is sa case 1, we considered improper integrals where the upper bound is approaching positive infinity. Dito sa case na to, yung sa lower bound naman, okay, mag-a-approach ng negative infinity. So according to case 2, if f is continuous for all x less than or equal to b, and the limit of this one as t approaches negative infinity exists, then the improper integral given by the integral of f of x dx from negative infinity to b is equal to the limit of the integral of f of x dx from t to b as t approaches negative infinity. So, ang nangyari lang dito is we replaced negative infinity by the variable t, and we let that t approach to negative infinity. Okay? So, same lang yung process ng case 1 and case 2. Yung bounds lang yung kaibahan. Case 1 ang gagamitin if the bound is, or the upper bound is approaching positive infinity. While case 2 ang gagamitin if the lower bound is negative infinity. Okay? So para mas maintindihan, let's try to solve this example here applying case 2. So this can be written as the limit of the integral of x times e raised to x dx. We will replace negative infinity by a variable t, and our b is 0 as t approaches negative infinity. Okay? So dito, first we will try to solve this definite integral first. Okay? So solving this definite integral, we have the integral of x times e raised to x dx from t to 0. Okay? So observe that this expression can be solved only if we will use integration by parts. So ang gagamitin is again integration by parts. Okay? So according to integration by parts, that is the integral of u dv is equal to uv minus the integral of v du. Okay? So we will identify our u and dv in our expression. So here, gagamitin kong u is, so I will let u be equal to x. So that means that du is equal to dx, and dv is equal to e raised to x dx. Therefore, v is equal to e raised to x. Okay? So, applying integration by parts, this is now equal to uv, which is x e raised to x. Take note, this is a definite integral, so we have bounds from t to 0 minus the integral of e raised to x dx from t to 0. Okay? So, evaluating this integral, copy lang muna natin yung first. Okay, from t to 0, this is just equal to e raised to x. Okay, evaluated from t to 0. Pwede nating i-combine itong dalawang terms na to. So this is just x e raised to x minus e raised to x, okay, from t to 0. Okay? And substituting, first we have 0 times e raised to 0 minus e raised to 0 minus t times e raised to t minus e raised to t. Okay, so this is 0 and this is 1. Therefore, the first term again, this is 0, while this is 1. So that means that we have negative 1 minus this one. Okay, t e raised to t and plus e raised to t. Okay, so this is now the result if we will evaluate the definite integral. So substituting that result to our problem, so this is just the limit of negative 1 minus t e raised to t plus e raised to t as t approaches negative infinity. So we will get the limit of the three terms here. First, limit of negative 1, then limit of t times e raised to t, and the limit of e raised to t. Okay? So dito, yung second and third term yung medyo kailangan nating isolve kasi yung limit of negative 1 is just negative 1. Okay? So therefore, here, first, we will solve this, then second, this one. Okay? So, solving for the limit of the second term, that is just the limit of t times e raised to t as t approaches negative infinity. Okay, so that is just equal to, we have, if we will try to substitute directly, so that will become negative infinity times e raised to negative infinity, right? And that is just the same as negative infinity over, para maging positive yung exponent, e raised to positive infinity. And e raised to positive infinity, okay, it will go to infinity. So therefore, we have negative infinity over infinity, which is an indeterminate form. Okay? Whenever we have an indeterminate form, we can solve the limit, okay, using L'Hopital's rule. According to L'Hopital's rule, we will just differentiate the numerator and also the denominator. So rewriting our limit, so this is just t e raised to t as t approaches negative infinity. Dapat maging quotient ito para magamit natin yung L'Hopital's rule. So I can rewrite this as t over e raised to negative t, right? As t approaches negative infinity. Okay? So from that, this is now the derivative of t is just 1, and the derivative of e raised to negative t is just negative of e raised to negative t as t approaches negative infinity. Okay? So this one, if you will try to do direct substitution, that is just 1 over negative infinity. So this will become negative of negative infinity, which is just infinity. So e raised to infinity is just infinity, and we have negative here, so this is negative infinity. Okay, so this is a very small number, okay, a negative number. So 1 over this is just equal to 0. So again, this one will approach to 0. So therefore, the limit of the second term is 0. While the third term, ito, ayan, the limit of e raised to t as t approaches negative infinity, the same concept. This is just the same as the limit of 1 over e raised to negative t as t approaches negative infinity. So if you will just substitute that negative infinity here, so that is negative of negative infinity, or just e to the infinity. So this is a very big number. 1 over a very big number will approach to 0. So therefore, the limit of the third term is 0. So from that, this is now equal to, So the limit of negative 1 is negative 1 minus 0 plus 0. Therefore, the final answer is negative 1. That means that our integral is convergent. Okay? So I hope that is clear.